Hello everyone, this is Mike. Today I'm looking at this fume extractor that I use when I'm soldering. It's basically a fan that I got from an old machine, and I installed a switch on it and a pair of alligator clips to connect it to my bench power supply, and I've been using it for a while. Um, Today I want to do some modifications on it. I want to connect it to the AC main plug instead of the bench power supply that I most of the time will be using for other things. Also, the switch itself is a little bit hard to use when I have a hot soldering iron in my hand, so I'd like to add some capacitive switches to turn the fan on and off. I also want to add some LED lights. This will help me light my work area while I'm soldering as well. The fan and the lights will have separate switches, so I could turn one or the other or both. So this setup will consume about 400 milliamps or less, so a small switch mode power supply will do. Now, although it's a 12 volts fan, I'm going to use 13 volts because I found that this will help with the fume extraction. I get a better result this way. And also it will help offset some of the voltage drop that's going to be lost across the MOSFETs that I will use as switches to turn it on and off. For this project, we will need a fan, a power supply, and this is a power supply that was a 12 volts power supply, and I have modified it to output 13 volts. You could see the details of that project in a previous video. Two capacitive switches, an AMS 1117 5 volts regulator. This will provide the power for the capacitive switches because 12 volts will just burn them out. And two IRLML 2502 N MOSFETs to use as switches. These MOSFETs can handle the load with ease. The capacitive switch connects to VCC and ground, and it outputs a high or a low depending on its state and its jumpers A and B. If jumper A is open, then the switch output will be high, which is VCC minus 0.7 volts when it's on, and low when it's off. If the jumper is closed, then the output is low when it's on and high when it's off. Also, when a jumper B is open, then the switch will be on when you're touching it and off when you're not touching it. If you want the output to latch, so you touch it, it turns on and stays on until you touch it again, then jumper B needs to be closed, which is what we're going to do in our situation here. And now to connect everything together. So we start by plugging the supply into AC main. That goes into the power supply, and we get plus 12 volts and ground out of it. Next, we connect the 5 volt regulator to ground and plus 12, and now we have ground plus 5 and 12. Connect 5 volts and ground to the capacitive switch, get the output into the gate of the MOSFET, then connect the source to ground and connect the drain to the negative lead of the LED or the fan. Also connect the plus 12 volt to the LED and to the fan, and there we go, we're done. Right now The switch is not latching, so we need to short jumper B, and then it will latch. There, it's latching now. Next, we're gonna cut a small board, like a breadboard, and use it to connect the MOSFET and the other connections to the switch. This connection turned out to be quite solid and robust. Now we add the MOSFET. Now, why am I using an SMD instead of through-hole component? It's because that's what I have at the moment. Next, we cut a strip of LED lights. These are 12 volts lights, and it's very hard to remove the water resistant plastic off of it. But there you go, it came off. Solder a positive and a negative lead to it. Those will be connected to plus 12 for the red wire and the drain of the MOSFET for the black wire. In the back, we connect the 12 volts to the fan and the LEDs, and a small piece to the 5-volt regulator. Connect an extension to the ground wire. Connect the 5-volt regulator between plus 12 and ground. And then protect it with a piece of shrink tube. Next, we connect the switches as per the diagram from before, plus 5 and ground to the switch, and the negative lead for the LED and the fan to the drain of the MOSFET. Tuck the wires away and secure the switch in with good old double-sided tape. Now we weld the connection to the power supply. I take very good care not to get the mains line and neutral close to each other's. I weld one on top and one on the bottom. I do the same for the DC output. And then this is a piece that you do not want to leave exposed. You don't want to touch it. You don't want it to touch the metal. So You could either put it in a box. I prefer to just put it in a shrink tube, uh, heat it up to be nice and tight, and now it's insulated from the environment. Finally, I will secure the cables with the hot glue and install a power plug. And now I have a nice fume extractor sitting proudly on my bench. I couldn't have gotten this suction power if I had left the power supply at 12 volts. It's pretty powerful.